Hi guys, this is Muskan Lalwani from Autonomous PG College Chhindwara. Today we will discuss the question paper of 2017 and 18. Our question is, explain the body-centered cubic lattice, which is a short answer type question and it contains the 5 marks. Now we'll discuss the answer. Body-centered cubic lattice. In this lattice, there is a one center or lattice point at each of the 8 corners of the unit cell and one lattice point at the center of the unit cell, as we can show in the figure. It is also called the BCC or I cell. One of the example of is alpha iron. Hence, each lattice point at the corner is the member of 8 unit cell. The contribution of the 8 lattice point at the corner of the cell to the one cell is 1 upon 8 multiplied by 8 is equals to 1. That is one lattice point or atom. In addition to this, there is a one lattice point at the center of the cell, as we see in the diagram. Hence, average number of the lattice point per unit cell is 1 plus 1 equals to 2. One of the example of this is alpha iron. Alpha iron is an example of the body-centered cubic lattice. It is a lattice constant is A equals to B equals to C equals to 2.86 Armstrong. Each unit cell has one atom at its 8th corner, which is a member of a 8 such cell. Moreover, there is a one atom at the body center of the each unit cell, which is a completely associated with that cell. Thus, the total number of the atom per unit cell equals to 2. As we discussed previously, 1 upon 8 into 8 plus 1 equals to 1 plus 1 equals to 2. So, total number of atom per unit cell is 2. Hi guys, this is Muskan Lalwani from Autonomous PG College Chhindwara. Today we will discuss the option question of 2017 and 18, question number 2, which is explain the reciprocal lattice. In the lattice of the crystal, there can be a number of the sets of parallel lattice plane, the distance between which and the orientation are difficult to imagine these lattice plane. I will suggest a method to express these lattice plane according to which the normal are drawn from the common origin on these different parallel lattice plane. The length of these normal is proportional to the lattice interval DHKL. Thus, this normal is expressed the orientation of plane and the separation between them. The end point of these normal make a lattice which is called the reciprocal lattice. Thus, we can say the reciprocal lattice is a lattice which is obtained from the end point of the normal drawn and the different parallel lattice plane from the common origin. Each lattice point of the reciprocal lattice expresses completely the set of the parallel lattice plane associated with each lattice point, that is, its distance from the origin give a lattice interval DHKL and its direction relative to the origin represent the orientation of the plane. Hence, we can say that each point of the reciprocal lattice is the characteristics of the associated set of the parallel lattice. In the diagram, we can see a crystal lattice. A crystal lattice contains a number of the parallel plane. As we can see in the diagram, A, B, C, D and E, F, G, H, which are the parallel planes. We see the Miller indices of this plane is HKL and the Miller indices of this plane is HKL because they are the parallel plane and the distance between these two planes is D. Now we will take an arbitrary point which is the origin and we draw the normal to plane EFGH. The length of this normal is inverse of DHKL. Similarly, we will draw the normal to the each and every plane and we get the array of the points which is known as reciprocal lattice. Today we have discussed the question paper 2017 and 18, question number 2 and its optional question. Explain the body-centered cubic lattice and explain the reciprocal lattice. I hope this video is very helpful to you by the exam point of view so that you can score the maximum marks. Thank you. If you like this video, please like, share and subscribe.